Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. So last time, we discovered how radians help us find arc length and the area of a sector. Today, we'll extend those ideas a little bit further. We're going to derive two important formulas. The first one is for the area of a triangle, and it's not the one that you're used to seeing. The second formula is the area of a segment. So let's get started. So here we have our triangle ABC. Our base is the side between the vertex A and the vertex C. So we've labeled that as our B. Now the height of this triangle is what we get if we go to our third vertex, which is B, and we drop a line straight down to our base, and it has to form a right angle. So that is going to be our height, H. So now the formula that you're used to seeing is that the area of this triangle is going to equal 1/2 times the base times the height. So now let's go ahead and derive another formula. But before we do that, let's first review how a triangle is labeled. So notice how we have our triangle ABC and we've labeled the vertices with capital letters. So by convention, to label the sides, we label them with lowercase letters. And we label it in such a way that the side across from each angle is the same letter. So for example, we have our angle A here, then that means the side across from it is going to be lowercase a. Similarly, we have our angle C here, so that means this side is lowercase c. And then the bottom side is across from vertex B, so it's going to be lowercase b. So now that we have our triangle properly labeled, let's go ahead and derive the second formula. So if you recall your trigonometric ratios from previous classes, we know that sine C is equal to opposite over hypotenuse. And in this case, the opposite is going to be the height, and the hypotenuse is going to be our lowercase a. So if we take this equation here and isolate our h, we're going to get h is equal to a times sine c. So now substituting this into the formula for the area of a triangle, we get the area is equal to 1/2 times a times b times sine angle c. So this formula here has the calculation for height h already baked in without needing to do it in a separate step. And that allows us to do our work with areas more efficiently. So let's take a look at an example. So here we're asked to find the area of a triangle where side A is equal to 8, side B has length 10, and our angle C is 60 degrees. So using the formula, we get the area is equal to 1/2 multiplied by A times B times sine C. So substituting in the numbers, we get this is 1/2 multiplied by 8 multiplied by 10 and sine of 60 degrees. And we could actually calculate sine 60 degrees without the use of a calculator because that's one of our special triangles. So let's go ahead and draw our special triangle here. So the special triangle is our 30, 60, 90 triangle. So we have 60 degrees here, 30 degrees here, and this is our right angle. And the sides are 1, 2, √3. So sine of 60 is going to be opposite over hypotenuse, which means that's going to be √3 over 2. So that means here, the area of our triangle is going to be 40 times √3 over 2, and that simplifies to 20 √3. So next, let's take a look at an area of a segment. So the area of a segment is this shaded region here. And looking at our diagram here, we can see that the area of a segment is just the area of the sector, which we have defined in the previous video, minus the area of this triangle here. So let's go ahead and write that down. So we have our area of our segment is equal to the area of the sector minus the area of the triangle. Now from the previous video, we know that the area of a sector is 1/2 multiplied by r squared multiplied by the angle theta. And again, remember that this theta must be in radians. And the area of the triangle is what we just covered, which is 1/2 multiplied by AB sine C. But here, our A and our B are both R. And then our angle C, which is in between the sides A and B, is angle theta. So therefore, the area of this triangle is going to be 1/2 multiplied by R, multiplied by another R, and then multiplied by sine theta. So if we go ahead and simplify this, we end up with the area of a segment is 1/2 R squared multiplied by theta minus sine theta. So now let's go ahead and take a look at an example. So if we have a circle that has radius 6, what is the area of a segment with a central angle of theta, which is equal to pi over 3? So the good thing here is our angle is already in terms of radians, because that's what we need in order to use the formula for the area of a sector. And if you're not yet familiar with radians, you can convert this to degrees. So pi over 3 is just 60 degrees, which means sine of pi over 3 is just equal to root 3 over 2, which we have just calculated above. So using the formula for the area of a segment, we get this is equal to 1/2 R squared multiplied by theta minus sine theta. So now we can go ahead and substitute in the values, which is 1/2 multiplied by 6 squared multiplied by pi over 3 minus root 3 over 2. And all we're going to do is simplify what's outside of the bracket. So 1/2 multiplied by 6 squared is going to be 18. And we're going to leave our answer in terms of pi. So this will be 18 times pi over 3 minus root 3 over 2. So for the last example in this video, we're going to take a look at a word problem. So here we have a water tank that has a circular cross-section of radius 5 meters. So let's go ahead and draw our water tank. So this here is our cross-section. So let's say that the water level is right here. So which means here, this is all water. So the surface of the water is this chord that I have just drawn. And this is at a depth h below the top, which means from the top to here, this is going to be h. So for part A, we want to find the central angle in radians that is subtended by the water surface in terms of h. So let's go ahead and draw our center. And then we're going to draw 2 lines to the edge of the water. So the central angle, let's call that theta, is this angle here. So we know that the circle has a radius of 5. So let's go ahead and label these 2. And in fact, we actually know the height of this as well. Since the length of this entire thing is just a radius, which is 5, and we know that the top segment is h, that tells us this segment here is going to be 5 minus h. And what we also know is that this line here is going to divide our angle theta in exactly half. So now using trig ratios, we know that cosine of half of theta is going to be equal to adjacent over hypotenuse. So our adjacent here is 5 minus h, and our hypotenuse is 5. To isolate our angle half theta, we're going to take the inverse cos of each side. So meaning for the left side, to cancel out the cos, we are going to do cos inverse, which means on the right-hand side, we're going to do the exact same thing. So now the left-hand side is going to be left with 1/2 theta, and then the right-hand side is going to be cos inverse of 5 minus h over 5. And another way to write the inverse cosine function, which you might also see in your book, is that it's just arc cos. So you can write this as arc cos of 5 minus h over 5. And lastly, we're going to multiply both sides by 2 to isolate our theta. So we get theta is equal to 2, and then we'll write this as arc cos of 5 minus h over 5. Next, we want to derive an expression for the area of the cross-sectional segment of the water in terms of h. So first, we know that the area of the water is going to be the area of the entire circle minus the area of the segment that's above the water. Now the area of a circle is just pi r squared, and since our r is equal to 5, the area of the circle is just 25 pi. So what we want to do next is we want to find what is the area of the segment. So using the formula that we just derived above, we know that the area of a segment is 1/2 r squared multiplied by theta minus sine theta. So substituting in the values that we know, this is going to be 1/2 multiplied by 5 squared, which is 25, multiplied by theta, which is 2 arc cos 5 minus h over 5, minus sine of 2 arc cos 5 minus h over 5. So therefore, the area of the cross-sectional segment of water is going to equal to 25 pi minus 25 over 2 times 2 arc cos of 5 minus h over 5 minus sine of 2 arc cos of 5 minus h over 5. So now finally, if h is equal to 2, evaluate the area of the water's cross-section. So we're going to take our previous formula and we're going to substitute in h is equal to 2. So that means the area of the water is equal to 25 pi minus 25 over 2 times 2 arc cos of 3 over 5 minus sine of 2 arc cos of 3 over 5. So on your calculator, arc cos is going to look like cosine with a little -1 on top. And that is usually on top of your cosine button. So to get there, you would just press second cos, and then that'll give you the inverse cosine function. So once you type all of that into your calculator, your final answer is going to come out to around 67, and this is going to be meters squared. So let's do a quick recap of everything that we covered in this video. We learned a different formula for the area of a triangle, where we didn't have to calculate the height of a triangle separately. It was baked into the formula. We learned what a segment is and how to calculate its area. And finally, we learned how to apply these two formulas with a real-life example. So now it is your turn to give this a try. Can you find the answer to the two parts of this problem here? Make sure to leave your answers in the comments below and let us know if you have any questions. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.